So thank you to Dr. Cusan for the invitation and for organizing this new lecture series. I hope the stuff that I'm going to present today is useful to you as a clinician, and I will try to avoid talking about anything in terms of formulas or anything complicated in terms of statistics. Oops. Hang on one second. Trying to switch slides. Okay. So I'm basically going to start with just a brief overview of the review process and then walk through each section of a manuscript with you and talk about some of the common mistakes or things that I'm looking for when I'm reviewing papers, and then finish with a brief discussion. So just to give you some background on myself, in addition to my responsibilities here at Columbia, I'm also a deputy statistical editor for the Journal of Thoracic and Cardiovascular Surgery, and I'm also a statistical editor for the American Journal of Drug and Alcohol Abuse. So I've reviewed a lot of papers in the last few years, and I've reviewed for other journals as well. And I just wanted to state that these are my personal thoughts, not necessarily the thoughts of the journal. This is from my own personal experience. And I wanted to make a mention of the fact that when we review papers, it's a service to the field. I don't get paid to do the reviews. And often there's a quick turnaround, so 14 days, 3 weeks. So as someone who's writing a paper, you want to make the review process as easy as possible for the reviewers. And if you're asked to review a paper, I encourage you to take that opportunity and do a good job, provide useful feedback. So some things to keep in mind. Pretty much all top-tier journals will require a statistical review of a manuscript, and many other lower-tier journals also require this. In fact, some journals also require what's called a quantitative author, so someone with a methods background. There's different criteria for this. Sometimes they require one of the authors to have an MPH or a PhD in the field. But at the same time, the statistical reviewers may not be statisticians. Again, not all statistical reviewers are statisticians. We'll talk about that later in the talk. And the statistical reviewer often works in the field, but is not necessarily an MD. So I'm not an MD. I don't often know all the terminology, so you should make sure that your paper is readable by a general audience. So have someone who's not working on the project review the paper to make sure that it's accessible. All right, so the advice I'm going to talk about today in the context of writing papers is also applicable to grant writing. And then one final point, or second to final point, is that the devil is really in the details. I have found statisticians to be among the most detail-oriented people, almost to a fault. So if there's a mistake in your paper, we're probably going to find it, right? So pay attention as closely as possible to the details. And then the last thing, and I take this really seriously, as a statistician, I feel like almost like an ethical gatekeeper, right? So are the interpretations in line with the results in the study design? Are the data being analyzed appropriately? Are they acknowledging what limitations there are to their study? And I don't want a paper to go out into the world unless I'm sure that it's ethically sound. So this is a huge responsibility that I take on. So we'll start first with the abstract. So the abstract is the most important part of the manuscript. Why? Anyone want to shout out an answer? In reality, what are people going to read in your manuscript? Probably just the abstract, right? So this is really where I'm going to spend a lot of attention as a reviewer to make sure that what's presented there accurately portrays the research that was done and tells the story of the paper. So keep it simple, and whether it's structured or unstructured, it should have the same main parts of the manuscript. So what should I be able to identify when I read the abstract as a statistical reviewer? Well, I want to know, what's the background? What gap in the literature is this study filling? What are the study aims? What are the study design? What is my main exposure variable? What is my main outcome variable? How are they measured? And what is my population of interest? Who is my study sample? There should also be key findings for each aim. So I realize you have a limited amount of space, so this is difficult to do. But ideally, you should have findings for each of your aims. And then lastly, something about the impact of the findings. So why should I care? How is this going to change practice? And to be honest, I don't really care so much about the statistical details in the abstract, right? I can read the methods section for that later. I'm much more interested in these other issues as the reviewer, right? So don't try and fit in, I fit a multi-level model, blah, 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 right? Just say something simple about how you analyze the data. And just so you know, we will be posting these slides, so you don't need to take notes right now if you don't want to. Any questions on the abstract? All right, so again, most important part of the paper, you really want to tell your story there. So introduction. So these are some of the key questions that I ask myself as I read an introduction. What do we already know about this problem? Is the problem clearly stated? I can't tell you how many times I've reviewed papers and I'm not even sure what they're trying to do, right? So if that's the case, it doesn't matter what your methods look like later. If I don't know what question you're trying to answer, I can't evaluate the rest of the paper. So what gap is the study filling in the literature? Why is this important? Why should I care? And then what are your study aims? And are they congruent with the problem that you just built up? So be as explicit as possible. Ideally, state a hypothesis, right? So not all research is hypothesis-driven. In that case, you should state that this is exploratory analyses. And then one last sort of reminder is that make sure that the aims that you list in your introduction match the results you're going to present later. So often I'll read the aims, move to the next section, get to the results, and I find things in there that were not stated in the introduction. So you want to have congruence between the two. So to get a little bit more technical, when I'm reading your introduction, it should be clear to me what X, Y, and P are. So this is going to be the extent of my algebra here. So X is my exposure variable, Y is my outcome, and P is my population of interest. These are the three key pieces of information that I need to know to move forward with the paper. And again, I should also have some idea of the study design. So you don't have to provide all the details, but I should know, is this a cohort? Is this an RCT? Is it cross-sectional? Because that's going to frame the rest of the review process for me. Right? So you're going to have plenty of space later to describe the design, but include 1 or 2 sentences on the design in the introduction to frame the rest of the paper. Questions about introduction? We're also going to have time at the end for questions, so if you want to save them for then, that's fine as well. Right, so tell me what the story is, why are we researching this particular topic, and then give me some more details. What is X, what is Y, what is P, and how are we going to examine those things? So for the methods section, we're going to walk through several different parts. So the first part is the study sample. So I need to know who you included in your study, who did you exclude, and are those reasonable inclusion and exclusion criteria? You should also tell me when you conducted your study. So when did you collect your data? What is your sample size? This seems obvious, but is often forgotten. So how many people did you include in your study? Even if it's in a table later, put it up front so people know what they're working with. You should also include some sort of study flow chart. So for a clinical trial, there's very standard reporting guidelines called the consort. So I have a picture there of what a typical consort looks like. You can go to their website to download the template. But I also wanted to state that the consort is a lot more than just a diagram. So there's a lot of reporting criteria that you need to meet with an RCT. That website's a really great resource for that. And then this Equator Network is another great resource for other study designs. So they've tried to take what's presented in the consort for RCTs and apply it to other study designs. So if you've done a cohort, case control, all sorts of designs, they try to give reporting criteria there for them as well. And when you're working through this diagram, make sure all of the numbers add up. Again, seems like common sense, but often it's not the case that that happens. So I will go through and count up the people and find, the ends don't match. And then the last part related to study sample is you need to tell me something about this group of people. So we want to always have that table 1 with study demographics. Who are the participants in this study? In the study design section, you should also say something about IRB approval and whether or not you had approval or if you had a waiver, you have to say something about that. Pretty much all of the journals I review for require me as a reviewer to check a box saying that I've checked for that piece of information in the paper. And if it's not there, your paper's not going to get accepted. If it's an RCT, we also have to make sure that it's registered in clinicaltrials.com or some equivalent. Actually, I think that should be clinicaltrials.gov. But basically, your RCT needs to be registered. So now we're going to come back to X, Y, and P. So again, what is your exposure? What is your outcome? What is your population of interest? So in terms of your exposure and your outcome, Things that I want to know is, how are you measuring that? How often are you measuring it? What types of variables are they? Are they binary? Are they continuous? What is your primary endpoint? So maybe you've collected multiple measures over time, but one particular assessment is of interest. You need to provide all of that information to the reader. And if you're doing some sort of longitudinal study with follow-up, you need to tell us about goodness of follow-up. So how many people dropped out? Why did they drop out? And how that might impact your results. These are the sort of things that I'm starting to think about when I read the study design section. So as a reviewer, my main goal when reading the design is to answer the following questions. So is the design appropriate to answer the questions they're interested in? Related to the design, what biases might be introduced by using such a design? So I'm going to be thinking about this as I read the paper, and hopefully when I get to your limitations section at the end of the paper, you're going to say something about the study design and how that might limit the generalizability or the interpretation of your findings. I'm also looking for something about sufficient number of patients and or events to answer the study questions. Right? So I'm thinking about power and sample size. So if necessary, depending on the journal and the type of study you're doing, you might include your power and sample size calculations in the manuscript. And if you're going to do this, you need to give me all of the information I need to replicate the results. And I have, in fact, done this myself. Whenever I review papers, especially for clinical trials, I'll plug the numbers into my software and make sure I get the same numbers as you. And one sort of big warning, make sure you don't confuse the total sample size with the per arm sample size. So a lot of software will compute the sample size for you, and it'll tell you you need 50 people. But really what it means is that you need 50 controls and 50 treatment people. This has happened in real life. I reviewed a paper. They had the protocol. Everything was in line, but they misinterpreted their power and sample size. So they had half the amount of people they needed. And they had a null finding, so it was really hard to interpret that paper given that mistake. So they had carried out all of this research, spent all of this money, and now we're not sure what to do with it. So please be careful. Make sure you double and triple check your software if you're using it. So any questions about study design and how to present that? Mm-hmm.
It's very useful for RCTs, like some of the cross-sectional retrospective chart review study.
Mm-hmm.
That'd be useful because you're just going to talk about who you excluded and you already described that.
Yeah, so if you check out this Equator network, they tried to basically come up with alternatives to the consort for those other types of study designs. So you can go in there and look for case control studies. What should you be including? So they'll give you more details on that. But you're right, it might not be exactly the same as the consort diagram. But there is an equivalent if you're interested in looking at it. And not all journals require you to do this, but I do find it's a useful resource as you're preparing your paper to think about what sorts of things need to end up in the paper, even if it's not required. Any other questions? Yep.
Can you share a little bit more about what you mean by parameters within the goodness of follow-up?
Sure. So let's say you're conducting a study, you're following people up for a year. It would be useful for me as a reviewer to know, well, how many people, let's say, made it to 3 months? How many people made it to 6 months, 9 months, and a year? So if you did your study for a year and you only had 10% of your sample left at the end of the year, is that really interesting and relevant? So that's what I mean by that, is just to provide some details on when are people dropping out and at what rate. And of course, you're going to have to now deal with that missing data later. You could also report, like, if you're doing a survival study, so median follow-up time, something like that, just to give a sense of how long people are remaining in the study. Great questions. The statistical methods section is probably the section I spend the most time reading. And the goal when you're writing this section is that another person should be able to read it and replicate your results. I realize that you have a limited amount of space in your manuscript, and I'll give a suggestion for how to handle this at the end of the talk. But specifically, what am I looking for? So I'm looking for methods that are cited for each objective. So if you have 3 aims, what are the analyses you're going to use for aim 1, aim 2, and aim 3? What test are you going to use? And then how are you going to handle the missing data? Right? So missing data is a reality of doing research. We always try to minimize missing data, but even given the best methods to sort of ensure complete data, we're always going to have things that come up. Right? So again, report how much missing data there is. If you're going to do a complete case analysis, so what that means is you're going to only include people who actually gave you data or completed the trial. You need to think about what are the potential biases and mention them in your limitations. Are you going to use imputation methods? Right, so there's a whole sort of universe of imputation methods. What's appropriate for your study? And I just wanted to warn against last observation carried forward. So in RCTs, a lot of people tend to use this last observation carried forward method, which means if someone drops out, you take the last available measurement that you have on them and carry it forward to their endpoint. There's a lot of bias associated with doing that. There are much better methods out there to handle missing data, so do not use last observation carried forward. And the other thing I will say relating to missing data is don't pretend like you didn't have missing data in your paper. That's a huge warning sign to me that you had something major go wrong with your study. Right? So if you just completely sort of sidestep the issue, as a reviewer, I'm going to be like, wait, what happened? Why are they not mentioning this? So you have to be upfront, you have to be explicit, and be as detailed as possible. And again, you may not necessarily be able to do some of these things, so imputation methods might be complex. Work with a statistician who can help you. So sort of the big question is, do the methods match the type of outcome data? Right, so this is not meant to be an exhaustive list, but just to give you a sense of some of the analyses I'm looking for, depending on the type of outcome you have. Right, so your outcome variable is going to drive the analysis. So if you have a continuous outcome, so something like blood pressure or weight, and you're comparing two groups, right? So you want to compare group A to group B. You could do something like a t-test. If you're comparing three groups, so group A to group B to group C, you want to use something like an ANOVA. You can also use a linear regression model in this case. And I have this under the column of unadjusted analyses because all we're interested in doing right now is comparing group A to group B. If we want to compare group A to group B, adjusting for some other information, so adjusting for age or gender or whatever, then we have to move towards linear regression. I just wanted to point out that we can use linear regression for both unadjusted and adjusted analyses. A lot of people think you have to do a t-test or an ANOVA and then move to linear regression later. You can use linear regression for both sets of analyses. Is everyone okay with what I mean by unadjusted versus adjusted? Anyone need any clarification? Okay. All right, so again, it's our outcome variable that's driving the analysis. So if we have a binary outcome, so death or no death, infection, no infection, and we're comparing two groups, there's a whole host of methods we can use. The most common are chi-square test, Fisher's exact test, and logistic regression. And again, we can use logistic regression for those unadjusted analyses and the adjusted analyses. And then the last most common type of outcome is time to event data. So time to heart attack, time to recovery, time to readmission or to remission. These are all time to event outcomes. We want to use survival methods. So we have Kaplan-Meier, which gets us our survival curves. That's a non-parametric estimate of survival. So it gives us those figures you're probably very familiar with. We're going to see one in a couple of slides. But if we want to compare two groups or two or more groups on those Kaplan-Meier curves, we have to use a log rank test. We can also fit a Cox proportional hazards model, both in the unadjusted and the adjusted case. And there are lots of other survival methods out there. These are just the most common. So this is, again, not an exhaustive list. These are the most traditional methods, and there's also a lot of non-parametric methods that are not listed here that might be of use to you. Right, so for me, when I'm reading the paper, I really need to know what the outcome is in order to assess whether the appropriate method was used. Any questions on this sort of table or the analysis technique? So I'm going to spend the most time talking about the common mistakes in the methods section. So the first is when conducting an RCT, for the most part, it's standard to carry out what's called an intent to treat analysis, which means you're going to randomize, you're going to analyze everybody that was randomized, whether or not they completed the study, whether or not they actually completed treatment. So if they're randomized to group A, you're going to analyze them in group A, and if they're randomized to group B, you're going to analyze them in group B. Missing data is a huge issue if you want to do an intent to treat analysis. So when I'm reviewing an RCT, I want to make sure that the authors actually carried out an RCT, or an intent to treat analysis. You can carry out other types of analyses as secondary analyses. So if you want to do a per protocol analysis, that's fine, but I'm expecting that to be a secondary analysis, not the primary analysis. Another really common mistake is analyses that are used in the results or presented in the results are not mentioned in the methods section. So a really common example is the log rank test. So people write in the methods that they're going to use Kaplan-Meier curves, and then they report about log rank test in the results. They don't mention the log rank test in the actual methods section. Right? So if you're going through your results section, make sure everything you report there shows up in your methods at least somewhere. I think next one is the bane of many statisticians' existence. So there's this word multivariable versus multivariate. So what do we mean by multivariable, and what do we mean by multivariate? So multivariable means that we have lots of predictors in our model, so we're adjusting for covariates. When we write multivariate, it means we have many outcomes that we're modeling at the same time. So multivariable is many x's, multivariate is many y's. And more often than not, people are fitting multivariable models, not multivariate models. Make sure you're not sort of interchanging those two. Those two things. They mean different things to statisticians. So when in doubt, I would say go with multivariable. Related to model building, you should be explicit on how you carried out your model building. How did you select what variables were going to be in the model? Did you use some sort of selection procedure, or did you use clinical judgment? All of that is fine, but you need to be explicit about it in the manuscript. And you should also clearly state what variables are in your model. Don't just say we adjusted for common covariates. Give the details. Questions on those first few common mistakes? Yep?
Regarding intention to treat analysis, you said that the difference between protocol and intention to treat is outcomes versus randomized. For example, for diseases that are particularly aggressive, people may have events or die before even getting randomized after being enrolled in the study.
Sure.
I thought the intention to treat included all of the people.
So as long as they haven't been randomized yet, it's okay. So if you enroll them in the study and the statistician hasn't randomized them yet and they drop out, that's okay because they're not randomized. As soon as you press that button and you assign someone to a treatment group, you need to keep them in that treatment group for the duration of the study. They can drop out, they could stop taking the medication, they can die. And how do you handle that? Well, that's a difficult issue, and you need to work with a statistician to figure that out. But if it's before randomization, it's okay.
So it doesn't go anywhere.
No. So it's really from randomization forward, that's where the clock starts. And in terms of the difference between the ITT, or the intention to treat, and the per protocol, the per protocol, one example would be only including people who actually take the full dose of treatment and excluding people who either drop out or switch arms or something like that. And those are useful, and they have practical implications, but usually the primary analysis should be intent to treat. There are exceptions to that rule, but most generally speaking, ITT is the way to go. Yep.
If I'm not sure which model would best fit my data and my research question, is it advisable to use software to actually make the decision for me between different models?
Yes and no. So I'm hesitant to say yes. Personally, I would prefer that the process is driven by your knowledge of the problem. So I think a good distinction is whether this is hypothesis-generated work or is this exploratory work. If it's exploratory work, then let the data choose the model for you. But even then, there's some caveats. So you probably don't want to choose the model and fit the model on the same data. So there's this idea of prediction and validation. So having training data and then testing data. But if you're doing hypothesis-driven research, hopefully you've already sort of worked out some of those details in previous studies, or you have pilot data that informs the research process. So if it's hypothesis-driven, your method should sort of be specified ahead of time. Right? You should be going into the paper already knowing how you're going to analyze the data. If it's exploratory, then you can sort of choose several different models, see which one does a good job, but then you have to be careful when you interpret it. Right? Don't over-interpret those results then. Yes.
Sorry, can I just
That's
follow
okay.
up?
Sure.
But I totally agree, and I thank you for the advice. But what I see in a lot of papers that have been published, and this may be a stupid example because I'm not a statistician, but I see people fitting linear regression lines through scatter plots that are clearly non-linear. So, is it then advisable to change it post hoc to actually have a better fit, or still stick with my a priori hypothesis?
So your a priori analysis plan could say that you're going to check for a quadratic effect of whatever, and then if that's not significant, so you can write that all up in your plan as long as you specify all of the steps you're going to take a priori before you sort of start digging into your data. I think it's okay. But again, if it's hypothesis driven, hopefully you have some previous research that shows you, the shape of that thing is not linear. It's some sort of strange function of time or something, whatever the example is. But again, even in that exploratory world, we want to be careful about sort of using our data too much and overfitting our data. Right? That's always something we want to be careful about. Other questions on this side of the room? Sorry, you guys are in my blind spot, so. Okay. Great questions. So another really common mistake is that information is not given on how things are modeled. Right? So this might be obvious to you when you're doing the analysis, but one common example is time. So there's lots of ways to treat time, and by time I mean historical time. So if your study is from 2002 to 2010, how are you taking time into account in your modeling strategy? Are you treating it linearly? Are you categorizing it? Are you dichotomizing it? There are lots of different ways. There's an infinite number of ways that you can include time in your model. So you have to be explicit on how you included it and potentially why you included it that way. Another common mistake related to variables and how they're modeled is categorical variables. So when you're modeling a categorical variable, you need to choose a reference group, right? So if you have, let's say, treatment A, B, and C, maybe you choose treatment A as the reference group. It doesn't matter from a modeling perspective, but in terms of interpreting the results that the model produces, it's really important to know what the reference group is. So I can't interpret the results if you don't tell me that group A was the reference group. And related to this, if you're choosing group A as your reference group, then you might give results for B versus A and C versus A. Right? That's sufficient information for me then. So you give me the two comparisons when you have 3 levels. Another really common mistake is that often we have data that are matched, repeated, or correlated. So we have before-after data. We have data collected over time. So let's say every month we collect data on the same person. We can't analyze this data using those traditional methods that I presented in that table. So all of those methods, so linear regression, logistic regression, t-tests, they all assume that we have independent observations. This is not the case when we have longitudinal or matched or repeated data. So if that's the case, you have to use a whole different group of methods. So there's the paired t-test, the McNamara's test, those are sort of the simplest. But then there's more complicated things like conditional logistic regression, mixed effects modeling, GEE. So definitely work with a statistician if you have repeated measures data. Don't just use sort of the off-the-shelf methods that you might have learned if you took an intro to biostats class. Those are not going to be sufficient in that case. And then another really, really common problem is that multiple comparisons is not accounted for. Right? So let's say you have 4 groups, and you want to compare each of the 4 groups to each other. Every time you do that comparison, you risk making a type 1 error. Right? So if you do that, I don't know how many comparisons that is, but it's a lot of comparisons. There's lots of chances to make a type 1 error. So you definitely want to think about that and control your type 1 error rate. Again, it's going to depend on whether you're doing this hypothesis-driven research. In that case, you definitely want to control your type 1 error. Or if you're maybe doing exploratory analysis, maybe then you don't need to be so concerned about that. But in general, you should be aware of multiple comparisons and have a plan to deal with it. So questions on these mistakes? Right, so these are all really difficult questions. Don't think that you need to tackle them on your own. Even the best statisticians will have a tough time handling some of these things. Just be aware that these are things that you have to worry about and that the reviewer is going to be looking for. So another really common issue is related to sample size or having a small number of events. So depending on what type of analysis you're doing, sometimes the overall sample size is really important and sometimes the number of events is important. So I've given several examples of this. So if you have a binary predictor and a binary outcome, you can make a 2x2 table. You might want to use a chi-square test. That's sort of the default method that people go to. But if you have small expected cell counts, I'm not going to get into what expected cell counts are, but basically if you have small counts in any of those cells, you shouldn't use a chi-square test. So your chi-square test is based on some large sample assumptions. In that case, you want to use something like Fisher's exact test. That's appropriate no matter what sort of sample sizes you have. If you're looking at a continuous outcome that's potentially skewed, and your sample size is small, you might not be able to use your standard t-test anymore. So you might have to use a non-parametric method like the Wilcoxon rank sum. Right? So if you have small sample sizes, you should be thinking about this and making sure that you're using appropriate methods. And then the last point I want to make about sample size. So when you're building models, people are often tempted to just throw variables in the model. So if you collected it, throw it in the model. But the number of variables you can include in your model is actually dependent on either the number of people in your study or the number of events. Right? So if you're fitting a linear regression, there's a rule of thumb that you can have one variable in the model per 10 people in your study. It's just a rule of thumb, but that's something to think about. Right? So if you have 100 people in your sample, you could include up to 10 covariates in your linear regression model. It gets a little bit more complicated for logistic regression, but it's the same idea. You're going to be limited by your sample size. So you can't put 100 variables into your model. So be careful, have a plan for what variables you're going to include and why. And again, always be explicit about that process. So questions about the small sample size. So the last sort of common mistake that I wanted to mention is related to time to event data. So the first thing is you want to make sure you're using survival analysis methods. So if you're modeling time to first heart attack, time to readmission, any of those types of things that involve time to the event, you want to use a survival analysis technique. Right? So Kaplan-Meier is the most common, Cox proportional hazards, those sorts of things. Related to how you write up your methods section, you need to be explicit about censoring. So what is censoring in your study? How are people censored? How are you going to handle deaths or dropouts? All of that information needs to be given to the reader. And then another really important issue related to survival analysis is competing risks. So let's say you're modeling time to first heart attack, and someone in your study dies before they have a heart attack. How do you handle that in your methods? Right? So once they die, they're no longer at risk of getting a heart attack. What do you do about that? Can you use standard methods? Again, these are complicated questions. You need to work with a statistician to help you with this, but just to be aware of these are the sorts of things you should be looking out for. Questions? Right, so again, there's a whole field of statistics just dealing with competing risks. So moving to the results section. Right, so the first thing I'm looking for is results for each of the objectives. So if you wrote in the introduction you had 3 aims, I'm expecting to see results for 3 aims. In general, do the numbers make up? Do they make sense? Do they add up? So what do I mean by this? Right, so if you're reporting a confidence interval and a p-value, is there agreement between the p-value and the confidence interval? Right, so if the confidence interval contains the null value, right, so if we're talking about an odds ratio, if a confidence interval contains 1, then your p-value should not be significant. Right? There are very rare cases where this might not be true, but in general, we expect for the confidence interval and the p-value to align. So if I see that sort of discrepancy, I know that something went wrong somewhere. And again, now that's raising red flags in my brain about who did this analysis, were they careful? And that's not something you want the statistical reviewer to be thinking about. So do the results match those in the abstract in the tables and figures? Again, this is a sign of sort of sloppy work. If you have one set of results in the results section and then a different set in the abstract or the tables and figures. Maybe you had one version, you updated it, and then you forgot to update other parts. All of this is giving me the sense that maybe you weren't very careful. And then I start to wonder, well, were you not careful with other parts of the analysis section? So I'm going to go back and be even more critical of my in the reviewing process. So are you reporting effect sizes and confidence intervals and not just p-values? So if you're saying that there's a significant difference between 2 groups, Don't just give me the p-value. Tell me what the mean is in group 1 and the mean is in group 2, and give me a confidence interval for the difference between two groups. A p-value is not very helpful to me other than it tells me, your p-value is bigger than 0.05 or less than 0.05. In terms of having sort of impact, you definitely have to have those effect sizes in your paper. And our next seminar, so a little advertisement, is going to be just about p-values, and whether or not we should trust them and how should we report them, and whether or not they should be banned by journals. So several journals have now banned p-values outright. My personal opinion is that's a little extreme, but you definitely want to include effect sizes and confidence intervals. And this also applies to Kaplan-Meier curves. So what do I mean by that? Okay, so that doesn't look so bad up there. Right, so here we're looking at time to some event, so lung cancer survival. So we have time on the x-axis, we have survival on the y-axis. The first thing I'd like to point out is that the axes are clearly labeled, which is good. And they're comparing two groups. So they're comparing that purple group to the blue group, so females to males. Often people will just include the dark lines. They don't include those confidence bands for their estimates. Right? And why are the confidence bands important? Why would I care about those as a reviewer? Right, so what am I looking at in terms of the confidence bands? So do they overlap a lot? Do they not overlap? I mean, I have my log rank test p-value there that's not labeled, but I'm assuming it's a log rank test p-value. So it's telling me those two groups are significantly different. But what do you notice as we move further in time? What's happening to our sample size? How many people are still in our study as we move further and further out? There's very few. So this last estimate at 1,000, I'm not sure if it's days or months or years because they didn't label their axes, but we'll get to that. Right, we have 2 people left, 2 males and no females. So how much should I trust the end of that survival curve? Probably not very much, right? And hopefully the confidence bands give you that sense, right? Because you can see how big the confidence bands get at the end. Right, so always provide those confidence bands. That's part 1. Part 2 is to always include this table here with the number at risk. Right, so you need to tell the audience, well, should they put a lot of weight at that end result? So if there were 200 people left, then maybe, but with 2 people left, I'm not going to really pay much attention to the end of the survival curve. I'm much more interested in the earlier part. So again, be honest. It's fine that there's only 2 people left, but you have to tell the reader that. Questions about the survival curves?
I guess I may be jumping ahead of the
Sure.
talk, but going back to your first point in the previous slide, there's a lot of times you have, especially in perspective, trial, comparison trial, ease of 0.06 and confidence interval of 1 to 10, or 0, 1 to 1.
Mm-hmm.
So there's often this debate about what's statistically significant and what's clinically meaningful.
Mm-hmm.
But then regulatory bodies, for example, for drug approvals, a lot of times go by statistically significant differences. And you were mentioning that some journals have. So I feel like it's a pretty heated debate.
For sure. And hopefully
you
then
should just present the results.
I think it's fine to report the 0.06, but then provide that confidence interval. Right, so you telling me that the confidence interval goes from, let's say, 0 to 10, that might be a very wide interval. That might be a very narrow interval, depending on the thing that we're talking about. Right, so piece of information that would be useful there is, well, what is the standard deviation for this particular measure? Right, so is a 10-unit change important, or is it not important? So maybe for cholesterol, a 10-point change is not meaningful, but on some other scale it is. The clinical significance part, I'm relying on you guys for. I can't do that as a statistician. But that's a conversation that the statistician and the clinician need to have together. And it's difficult, right? So you get your p-value of 0.06. You're like, it's so close, right? But just be honest and disclose what you did. Provide the p-value, give the effect sizes. And in the discussion, you should say something about whether or not that's clinically meaningful. If it's a 0.06 p-value and the effect size is really small, then what does it matter? Right? But if it's 0.06 and it's a big effect size, then maybe you need to do future research to confirm that result. It's a hard balance. But I think the most important message that I could give you is just to be honest. Don't try to hide things from the reviewer. Again, you don't want to sort of send up red flags because then they're going to go back and review everything that much more carefully. So I tried to make this as, to sort of warn you of this as much as possible because I see this all of the time, right? So don't carry out redundant analyses. So what do I mean by this? So I have a simple example here. So suppose you're interested in the relationship between smoking status, so binary, and heart disease. So yes, no, binary. First, you do a chi-square test to see if there's an association between the two. Then, in your next step, you fit a logistic model with heart disease as your outcome and smoking status as your predictor. And then you do a hypothesis test based on that logistic regression model. Those two things are testing the exact same hypothesis. So without adjusting for any covariates, is there an association between smoking status and heart disease? Generally, the results are going to agree. There might be slight discrepancies, but you should state ahead of time which one is your primary analysis. But don't report both as if they're two different findings. Again, that's a huge red flag to me that the statistical author on the paper wasn't heavily involved, right? Because a statistician would know that those two things mean the same thing, and therefore you shouldn't include both. So just be careful that you're not including redundant analyses. It will raise a red flag if you do. So tables and figures. So after the abstract, probably the most important. Why? If people are going to read anything other than your abstract, what are they going to do? They're going to probably look at the tables and figures, right? So you want to spend a lot of time on these and make sure that they're perfect. So make sure that they're labeled. If you're using abbreviations throughout the manuscript, don't assume that someone has read the manuscript. Spell things out on the tables and figures. Again, don't just give me p-values. I want to see effect sizes. I want to see test statistics, degrees of freedom. It's going to depend on the journal, but not just the p-value. If appropriate, report column or row percents. People often interchange these and get them confused. Make sure you're reporting the right kind of percent. And if you're going to have plots, make sure that the plot has a title. Make sure it has a y-axis and an x-axis label. Make sure you include units. Right, so we were just looking at that Kaplan-Meier curve. I didn't know if time was days, years, months. So make sure that the reader knows what you're talking about, even if they haven't read your paper. Any questions about tables and figures? So last section, discussion. So what am I looking for here? So are the conclusions in line with the data? Are you overselling what you found? Are you being honest? Are the claims supported by the results presented? How are these new findings fitting into the literature? Do they agree with what other people found, or are these new findings? What are the limitations? Right, this is, to me, as the reviewer, the most important paragraph in the discussion. So what are biases that you have to be worried about? This might be related to study design. And then specifically related to statistical issues. Talk about things like low power. How did you handle missing data? I want to know how all of those decisions might impact these results. And avoid presenting new results or data. So if you have new results or data, you're putting them in the discussion, stop, go back to the results section and update that first. Don't put new findings in the discussion section. So sort of ran through all of the sections of the manuscript. And I want to give you just some overarching guidance in terms of responding to reviews. So hopefully you submit your paper, they want a revision. Now you have to go point by point and address the reviewer's concerns. I think it's usually easy to identify the statistical reviewer. Is that true? Can you guys usually tell when you read the reviews which one was the statistician? I would assume it's pretty easy. Start by reviewing the criticisms with your statistical collaborator. Hopefully you already have one. Right? So hopefully this is not the point where you're going and finding a statistician to work with. You don't have to make all of the changes that the reviewer suggests. If you are going to go against their advice, be respectful and try to provide references for why you're doing what you're doing. The statistician isn't always right. I put here misinformed. I was trying to be polite. Right? So again, sometimes the statistician or the statistical reviewer is not actually a statistician by training. They're a clinician who has a lot of experience and methods. So they might not know all there is to know about statistics. They might not be up to date on what's the most current method. Again, it's fine to disagree, be respectful, and try and provide support for why you're making those decisions. And then just sort of as an aside from my experience, a good editor will get a second opinion. So if the reviewer and the authors are going back and forth about what is the best method or the best approach, they will often call in a second statistician to review the paper and give their opinion. So I've been what I call a tiebreaker before. So the editor contacted me and said, hey, the reviewer and the authors can't seem to agree on this. I don't know what to do with it. Can you please take a look and give me your opinion? So don't worry if there's this back and forth process, as long as you feel like you're grounded in research. So some final thoughts just to wrap up the talk. Ideally, you should begin working with a statistician before you even start your study. So before you collect any data, come talk to one of us. Have your statistical collaborator review the manuscript before submission. If they're a co-author on the paper, you should be getting their approval anyway to submit it. Include your statistician in the revision process. Don't go at it alone. And then in terms of space, so I often, from working with clinicians, have heard, well, we don't have space to put all of those details. How do you handle that, right, specifically related to the methods? Include an appendix with all of the details. And you could even include code in your appendix, which I recommend doing if possible, so that someone can reproduce your results. Right? Reproducibility going forward is crucial. So be as open as you can. Provide what you can't fit in the manuscript in an appendix. Good luck with your manuscripts, and thanks for listening. And we have a few minutes for questions, I think.
Thank you, Dr. Mauro. Thank you again. And any questions for Dr. Mauro or the statistical review? Yep, yes.
I read a lot of manuscripts that people say there's a trend, it's just a first amount of making results. What do you do as a reviewer to feedback?
I think it depends on the statistician reviewing the paper. I know some statisticians who will not let people use that language at all. For me, I'm a little bit more pragmatic about it. I think it's okay as long as you're explicit about what is the effect size, what is the confidence interval, so I can make a decision for myself whether that trend is really meaningful or not. But some statisticians feel very strongly that you shouldn't even say that at all. Other questions? Thanks everybody for listening.